Determine if f and g is linear or exponential, explain why, and then write a formula for each function. A function is linear if it is of the form y equals mx plus b, with m being the slope. And with the linear function, the slope has to be constant, meaning we add the same number each time or subtract the same number each time. An exponential function is a function of the form y equals ab to the x, where a is the initial value and b is the same ratio each time. B is also known as the multiplying factor. And so, to identify linear or exponential, we just simply want to know whether for the same increment in the x, in this case, x increased by 1 each time, we want to know whether the y value of the function is increasing by a constant number, or is it being multiplied by the same number? If it is being added or subtracted the same number, then it is linear. If it is being multiplied or divided by the same number, then it is exponential. We observe that for the function f of x, the values start with 70, and then it goes to 40, and then to 10, and then to negative 20. And so for each increase in x, the y values decreases by 30, and we do that by taking 40 minus 70, ending minus beginning, and then 10 minus 40, and then minus 20 minus 10. We take any two consecutive y values and subtract them, ending minus beginning, and we see that we subtract the same number each time. So the function f must be linear. We cannot say the same thing with the function g, because if we take 49 minus 70 and then 34.3 minus 49, we see that the differences are not the same. So we know g is not linear. And so to check whether this is exponential or not, we take the ending divided by the beginning, and we test again. 34.3 divided by 49, and then 24.01 divided by 34.3, because we want to know what number it is being multiplied. If we were to take 49 and then divide it by 70, we will get 0.7. We don't want to take 70 divided by 49 because we want to know what is that number we multiply to 70 to get 49. Notice that 70 times 0.7 will give us 49. Similarly, 34.3 divided by 49 will also give us 0.7. So this is promising, but we have to keep checking. 24.01 divided by 34.3 is also 0.7. And so we see that for the function g, we are multiplying the same ratio each time. And so g is exponential. Armed with this information, we're going to write a formula for f and a formula for g. The function f is linear, so f of x equals mx plus b. We saw that m is the constant rate of change, and so the slope is negative 30. It is the number that being subtracted each time. X is the variable x. B is the initial value when x is 0. we don't have that information, but if we were to put 0 in the table, if going forward from 1 to 2 we subtract 30, then going backward we would need to add 30. And so we know that when x equals to 0, the function f of 0 must be 100. And so this is the formula for the linear function. We can check that this works because if we were to plug in 1, f of 1 is negative 30 times 1 plus 100 is 70. F of 2, if we were to plug 2 into x, negative 30 times 2 is negative 60 plus 100 is 40, and so on. Next, for the function g of x, exponential of the form ab to the x. A is the initial value and b is the multiplying factor. We saw that the multiplying factor is 0.7. X is the variable. Similar to the linear function, if going forward we multiply 0.7, then going backward we would divide by 0.7. And so if we were to take 70 and divide it by 0.7, we will get 100. And so the initial value is 100. The multiplying factor is 0.7, and this is an exponential function for g of x. We can also check if this function works as well. When we plug in 1, we get 100 times 0.7, which is 70. When we plugged in 2, 0.7 raised to the 2 power is 0.49. 0.49 times 100 is 49.